Welcome to our lecture online. Now, the weathering on Mars of the Martian surface is a very different process than what occurs on the Earth. Of course, on the Earth we have a thick atmosphere, we have a lot of weathering, we have rain, snow, wind, sleet, running river, running water. We have all kinds of things that change and reshape the surface of the Earth all the time. In addition to that, there's a lot of volcanic activity and also a lot of uplifting. So rocks from deep below in the crust sometimes get lifted up to the surface, and so that's where we find a lot of these metamorphic rocks and granite-type rocks on the surface of the Earth, which are much more rare on Mars. Not that they're not there, but they're probably within the crust. But what do we mean by the special weathering process on Mars? Well, Mars has a very thin atmosphere, and because of the very thin atmosphere and also the lack of any significant magnetic field, the rays coming in, the cosmic rays coming in, are really not impeded and slam onto the surface with their full intensity. And what that means is that when they come down onto the surface and they reach the rocks on the surface of Mars, those rays actually penetrate the surface of those rocks. They go into the rocks and they change the chemical shape, or not the chemical shape, but the chemical consistency of the rocks by changing the isotopes of the rocks, let me say it again, by changing the isotopes. They're creating isotopes of the minerals that are within the rocks of Mars. And so, of course, that is something that we should warn travelers to Mars about. These particles are very dangerous. They cause a lot of radiation damage. They penetrate spacesuits, they penetrate rocks, they penetrate walls. And so when you're going to travel to Mars, you're also susceptible to this rain of cosmic rays that comes in on a constant basis. But what can we gather from the information of that rain of cosmic rays onto the surface of Mars? Well, it turns out that if a rock is being covered up by dust and debris and rhyolite and whatever, then the rays do not penetrate. But then as soon as the wind blows them free and they become exposed to the surface, then they exhibit, or then they experience that rain of cosmic rays. And the longer the rain has been taking place, and of course take rain with a grain of salt, so to speak, these are rain of cosmic particles, very high energy particles coming in at very high speeds from space. And the longer they're exposed to these rays, the greater the change, the greater the formation of the isotopes. Now, the isotopes are primarily in the form of helium, neon, and argon. And so we can kind of estimate how long rocks have been exposed to this rain of cosmic particles by the amount of isotopes that they've created over time. So it's kind of like a time window. It's kind of like a time measurement on the surface of Mars. And what we then gain from that is, of course, the Martian crust in the northern hemisphere consists primarily of quartz-rich dacites and granite rocks, or dacites, pronounced dacites, and granite rocks. Dacites are what we call very fine-grained igneous rocks. Remember that the igneous rocks in the northern half of the planet are very different from the basaltic rocks in the southern half of the planet. But most of these are covered by basaltic flows, so it's very difficult for lava flows. It's very difficult to identify what the crust of Mars is really made out of, because over time a lot of the crust is being covered over by basaltic flows, by lava flows, and so there aren't that many places where the subsurface rocks come to the surface through the erosion, through the sandstorms, to the dirt and sandstorms the sand being moved around. And so what we find is that the rocks that do get exposed, depending upon how long they've been exposed, we can then figure out a time scale to that. And so from that, we then realized that yes, when rocks have been exposed long enough time, we can then identify the isotopes in there. We can identify that there's various types of minerals and various types of rock formations below the surface, and they're then primarily being covered by basaltic flow. So again, we're trying to get a picture of what the crust of Mars looks like and what the surface of Mars looks like based upon the analysis of all these various methodologies that we used. So be forewarned, if you're going to travel to Mars, you are going to be susceptible to these cosmic rays. But meanwhile, these cosmic rays also offer to us quite an insight to the change of the surface of Mars. We can also see how much of the surface has changed over time and how long it's taken to go through those changes. It is quite amazing the amount of information we've been able to gather simply from these natural processes, and by the scanned information we've been able to glean both from orbiters taking the data from space, and then also from the few landers that have landed on the surface that have gathered information from actual doing sampling and detection of what is on the surface of the planet as well. So it's quite amazing that we have indeed discover quite a bit of information on the planet just by these few natural processes and understanding what they can tell us.